Assalamu alaikum warahmatullahi wabarakatuh. Yeah, welcome to our today's lesson. I will have a lesson on integrated science, that is chemistry part, the 9 chemistry part that I'll be teaching today. I'll talk about elements. That's exactly what I'm going to look at today. So guys, let's go together. If you have a child at home, you have a grade 9 at home, allow the child to join the live so that we can move together with our lesson today. So those who are at home, everybody watching me, welcome for today's lesson. Today we're going to have an interactive lesson. There's a lesson on integrated science. These are strand. These are a pathway when it comes to CBE. So guys, okay, welcome. Nimeona kuna Jenzi Mugambi. Jenzi safi, naona umeingia. Yeah, teacher Sam, nimeona teacher Sam amefika. That's nice. So today I want us to look at elements. I want to look at this the first topic. That's the first topic of integrated science grade 9. First topic of integrated science grade 9. And when we look at it, I know some of you are taught about this topic 1, which is the mixtures, elements, and compounds. In grade 7, you are able to discuss about the mixtures. In grade 8, you are able to look at element, what is an element. You are able to look at what is an atom. Yeah, like that. And now we have, in grade 9, we just expand what you learned in grade 8. That is mainly, if you looked at the elements in grade 8, in grade 8 you're able to look at the 20 elements in the periodic table. You are able also to look at, the other elements, the one that they are formed from the Latin words. Yeah, we have those others like the zinc. Those are other elements that are formed. We add them to the 20 elements that we learn in grade 8. Now in grade 9, here now we still now expound the element part. Here what we do is just to expound, and we shall be looking at now these elements. You look at it as now to try to look at these elements, the electron configuration, the electron arrangement. After that, you are able to define, to categorize them into metals, non-metals, and the ones that are neither metal or non-metal. So that is where mainly our lesson today is going to range. So mainly I want, as we start, that is the scope of today's lesson. Yeah, we have those ones who are asking me, oh, what are you going to learn today? What is the scope of today? This is okay. I hope mnanipata kule muliko. Those who are at home, those who are eating supper, kuna wale wanakula supper saa hizi. Yeah, for those who are at home, I hope you are getting me. Okay. Now, so we start by having what is an element, or an element. For you to know an element, we get to know first we get to know the atoms, and we are able to get to know what is a molecule. That on learning grade 8. We get to know what is a compound. Then after that, now we come in grade 9. We just now, after looking at that, we now look at the structure of an atom. An atom is the smallest part particle that forms an element. So after now knowing the atom, we now look at the structure of the atom. We look at what is this atom? Yeah, the structure of an atom. Now we get that an atom, it has two regions. Yeah, we have the region we call the nucleus, and you have the region that we call the energy level. Those are the two regions that forms an atom. Now the nucleus, you'll get that the nucleus, I'm still working on my voice. That's better. That's now better. At least you can now see me clear. Okay, hapo iko sawa, sivyo? Niko sawa. Sawa. Good. So we can continue now. I was talking about the atom, and you say that an atom, the smallest part of an element, it has two regions. That is the nucleus and the energy level. The nucleus contains some subatomic particles, the one we call the protons, and we have the neutrons inside the nucleus. Then on the energy level, we get what we call in the energy level, we get the electrons. We get the electrons. So those are the subatomic particles that forms an atom. The one that forms an atom. Then from there, we now look at what's a proton? Yeah, by the way, what are these protons? Protons are the positively charged they are positively charged. The positive charge in an atom. Then we get an electron. An electron is a negative charge in an atom. Then they can ask you somewhere, how do we say that, or why do we say that an atom is electrically neutral? This is because you get that it contains both positive charge and negative charge, which are equal in number. That is, the protons and electrons are equal in number. Then, so let's look at, there's something called the representation. We have an atomic number and you have the mass number. You get that an atomic number is the number of electrons in an element. When you look at the electron, for example, you have hydrogen. Hydrogen's electron is a element number 1 in the periodic table. It has 1 electron. That means when you look at it, is also 1 atomic number. When they ask the atomic number of an element, it depends with the number of electrons in the element. That's now the atomic number. Then there's something called mass number. If they ask you about mass number is just the total number of atomic number and the total, and when you add atomic number and neutrons, you get the mass number. Now you will get that the atomic number is usually the same number with the protons, the same number with the electrons. So if an element, let's say for example element number 8, which is oxygen. Oxygen is element number 8. Now this oxygen, it has 8 protons, and the same way it has 8 electrons, and the atomic number of oxygen is 8. So it means these 3, they work together. They are the same. They work together. So when you look at it, when you look at the protons, they are the same with the number of electrons and the atomic number. So when sometimes they can ask you the mass number. if they ask you the mass number of an element, if they ask you the mass number, you have to get the either the atomic number or what we call the protons or what we call or what we call the, you can get the protons, you can get the electrons, or we get the atomic number, and you add to the neutrons. You add to the neutrons, to the neutrons. Yeah, you will get the mass number. You will get the mass number. So that means that if you take the neutrons, add it to the atomic number, or add it to the electrons, or add it to the protons, you will get the mass number. That is what we call the mass number. So when they ask you the difference between atomic number and mass number is the total number of the protons, and the neutrons, will get the mass number. But if they ask you about, let's say, for example, they're asking you about the atomic number, that was just the number of electrons in the element. Now, here comes something called electron configuration. Let me start with that. Electron configuration. Sometimes we'll get it being called electron arrangement. Now, you know your atomic number. You know your atomic number. You know the elements, order of this element from element number 1 to element number 20, from hydrogen all the way to calcium. Now, when you have those elements arranged like that, let's say, for example, you have element number 1, which is hydrogen. Hydrogen is just standing on its own, element number 1. And before you come up with your electron configuration, you must be able to follow the rule. And which rule is it? You know the rule states that for you to write the electron configuration, ensure that the energy level should have at most, the first energy level contain not more than 2 electrons. From the second, the third, and the fourth energy levels, we have a maximum of 8 electrons. So that means when you have like hydrogen will only have 1. So that means it will only have 1. It has not even reached the maximum number of the first energy level. Same to helium, which is number 2. Also, it has only 2. But now, when we start with lithium, beryllium, boron, carbon, nitrogen, oxygen, like that, up to calcium, you will get that now. They now start following the rules. They'll have to follow the rules. We shall say that if the first one, for example, if we have energy number, let's say element number 10. Yeah, element number 10. So this number 10, if we have number 10, that is we can have element number 10, which is neon. This number 10, we shall start with, it has 10 electrons. So if it has 10 electrons, we shall start with the 2 in the first energy level. Then we now remain with 2, when you subtract from 10, it will remain with 8. That means the next one will have 8. So we shall have 2.8. That is 10 electrons. If you have calcium, it has 20. You will start with the rule. The rule says that the first energy level must have 2 electrons. in the outermost energy level. The first one must have 2. So if the first one has 2, that means you will start with those 2. Remember, you have 20 electrons. You remain with 18. From 2, you put there a dot. You move to 8. Remember, we said from the second energy level, maximum is 8. You write there 8. You now have 10. You have remained with 10. You write there another 8. You put there dot 8. You now have 18. 2 dot 8 dot 8 dot 2, because they're supposed to be 20. That one, you have written your electron arrangement. You have written your electron arrangement. So if you want electron arrangement, you just know the atomic number. You must know the atomic number first. You must be able to know this element from element number 1 all the way to element number 20. These 20 elements are the ones that mainly they are taught in grade 9. So grade 9s who are listening to me, if you know the arrangement of those 20 elements, then that means you are able to get the electron arrangement very well. You are able to get the atomic number, the mass number very well without any problem. Now, from there, after electron arrangement, we move to what we call electron representation. There is something we say that they can tell you represent the atomic number and mass number in one element, element maybe number 11. Now, when they talk about representation here, we shall have what we call a subscript and a superscript. We have a subscript and a superscript. Now, you know that there's an element sodium. Sodium is element number 11. Sodium, it has 11 electrons. So that means the atomic number of sodium is 11. Now, when you are writing the representation, the superscript is the one that you write on top, and it should be on the left side. Top, left side. Now, here we use the element, which is usually we use the letter X. That is the element. Then on top, we have what we call the mass number. On top left of the element. On the bottom left, we have the atomic number. So the superscript is the mass number, and the subscript, which is on the bottom, it is the atomic number. So atomic number is a subscript as the